Somewhere out there is a face. No camera ever caught it. All we have is one witness and a feeling. So how do you find someone you can only imagine? A sketch artist can't read the witness's mind and can't write down the rule that turns a memory into a face. But they can do one thing: draw a guess. Hold it up and ask, warmer or colder? Every model in science hits this wall. We can run it forward, turning causes into data. We just can't run it backward to read the causes off the data. The likelihood is closed. So we draw. Bayes wants the posterior, the parameters given the data, and it needs the likelihood to get there. When the likelihood is out of reach, Approximate Bayesian Computation trades it for a simulator. Propose a face from the prior. Draw it, simulate data. Compare to the witness. If it's close enough within a tolerance, epsilon, keep it. If not, let it go. No likelihood, evaluate it. Just draw, judge, keep. But here's the catch. The witness doesn't remember a fingerprint, they remember a feeling. A heavy brow, kind eyes, a certain set of the jaw. And many different faces carry the same feeling. So close enough never returns one answer. It returns a wall of faces that all fit some more strongly than others. That wall isn't failure. It's the shape of what we actually know. We never compare the whole image, we compare a few features, a summary statistic, through a distance. That's what close enough measures. And because a summary throws information away, many parameters map to the same one. So the keepers form a cloud, a distribution, the approximate posterior. Shrink the tolerance toward 0, and the cloud sharpens to the true posterior if the features were rich enough to begin with. But there's a price. The tighter you demand, the fewer guesses survive. Accuracy and patience pull against each other. Throwing darts at the whole space of faces and hoping one lands, you draw forever. A good detective doesn't start over, they work in sessions. Keep the near misses from the last round. Redraw them, small variations on what already worked. And each session, raise the bar for what counts as close. The search stops wandering and starts closing in. This is the engine, a sequence of shrinking tolerances. Start loose, almost anything passes, and you get a rough population of candidates. Then tighten. For the next round, don't sample blindly. Pick a survivor, in proportion to its weight, and nudge it a small perturbation. Simulate, and test against the new, tighter bar. Round after round, the tolerance falls, the population migrates, and the faces concentrate on the region that truly fits. A sequence of easy problems, solved in order, instead of one impossible one. And because every guess is drawn and judged on its own, you don't need one artist, you can fill the room. 1,000 easels, all working at once. The simulations are independent, so the work spreads across every core you have. The cloud thins, tightens, and the face you could only feel resolves into one you can finally see. 3 dials keep it honest. First, the weight. Because we breed from survivors, not from the prior, each keeper is reweighted its prior probability over how likely the perturbations were to land there. That correction is what keeps the posterior unbiased. Second, the tolerance sets itself. Each round's bar is a quantile of last round's distances, so the cooling adapts to the data. Third, the perturbation matches the population's own, spread its covariance widening when the cloud is broad, tightening as it shrinks. And one gauge watches for collapse, the effective sample size. If a few faces hoard all the weight, the search is starving, and PyABC says so. So when do you reach for this? When the forward model is easy, but the likelihood is a wall. Stochastic systems, agent models, the nonlinear differential equation, networks of systems pharmacology, where you can simulate a patient but never write the density. That's ABC's home. The honest cost. It's approximate, it's hungry for simulations, and it strains when the parameters run to high dimension or the features are poorly chosen. When you can write the likelihood, write it and reach for MC-MC instead. Use the sketch only when you can't photograph. What ABC returns isn't a single face, it's the posterior, uncertainty and all. And the loop has famous relatives. The population machinery is sequential Monte Carlo, the same particle filtering that tracks a signal through noise. The cooling and the perturbation are tempering and mutation, annealing and evolution by other names. And the newest cousins replace the witness's judgment with a neural network that learns the accept or eject directly. Simulation-based inference. Same instinct guess, compare, refine wearing different clothes. You can't always photograph the truth. But if you can draw it, judge it, and redraw, you can find it. Approximate Bayesian computation, the method that sketches its way to the answer.